We are starting our next unit, which is polynomials and factoring. You can read the essential understanding there for the key concepts for this first part of this unit. You can use monomials to form larger expressions called polynomials, and polynomials can actually be added and subtracted. There's other things you can do with polynomials, but that's what we're going to focus on first. Now, there are several vocabulary terms that you need. You should already have these in your vocabulary notebook. So you want to double check and make sure you have all of those. Having these definitions will help increase your understanding for each one of these examples that we're going to do. So please refer back to these definitions as we go through these examples. All right, so looking at problem number 1, it says, what is the degree of each monomial? We've got part A. Thinking about your definition of a monomial, you know that 5x is a monomial because it's the product of a real number and a variable. Product meaning multiplication. And we want to find the degree of this monomial. Well, you're going to have to go back again to the definition of degree of a monomial. And that simply means you add the exponents of the variables. In the monomial, you add the exponents of the variables. Well, we have one variable, and that's x. And what's the exponent? The exponent is the understood 1. So the degree of this monomial is just 1. I only have one variable. The exponent is 1. So the degree of this monomial is 1. Okay, so let's look at another example. Part B here, we've got 6x to the third, y to the second. Again, this is still a monomial. There are 3 factors. 6, x to the third, and y squared. Those are my 3 factors. But it is a multiplication, it is a product of a number, a coefficient, and variables. So that remains a monomial. Basically, there's no addition or subtraction here for what we've looked at. So this is a monomial. Now, the degree of a monomial, again, reminder, the definition of that was the sum of the exponents of the variables. Sum meaning addition. So you add the exponents on the variables. So x has a 3, y has a 2, so we're simply going to add those exponents. Their sum is 5, so that's the degree of that monomial. All right, so let's look at this example. All we have is a 4. But again, thinking back to the definition of monomial, we can have just a real number or just a variable or the product of a real number and variables. So this is still a monomial. It's just simply a constant. It's 4. All right, so when we talk about the degree being the exponent on the variable, there's not one. Now we could write it as x to the 0 because we know that x to the 0 power is 1, so it doesn't change the value here, but the degree of this constant is 0. There's not an exponent. Well, there's not a variable. The exponent would be 0 if we had a variable, so that's the degree. All right, so now it's your turn. I want you to look at this example. It's very simple, and I want you to come up with the degree of that monomial. Here are some answer choices. Pause the video if you need to. This may not take you very long, and find that degree. All right. Your answer is 2, and it's very simple. All you had to do was just add your exponents, which each one of those had a 1. The degree is 2. 1 plus 1 is 2. All right, let's take a look at another example. This one deals with actually adding and subtracting monomials, and you've been doing this for a long time now. You just didn't call it adding and subtracting monomials. You were just simply collecting like terms. These are like terms because 3 and 5 are your coefficients, and the variables that are attached to those coefficients are identical. X squared, x squared. Okay? So basically what you're going to do is just combine your like terms. So 3x squared plus 5x squared, 3x squareds in one hand, 5x squareds in the other hand. You would tell me you have 8x squareds altogether. Now the question over here is something to think about. Will the sum of 2 monomials always be a monomial? No, the monomials must be like terms. If these are not like terms, then you can't put them together. You would just be finished. In this case, they are, so we could put them together. If they're not like terms, we cannot combine them. All right, so that was a sum example. This is a difference example, difference meaning subtraction. The coefficient of this monomial is 4. X cubed y are the variables that are attached to that coefficient. The coefficient of this monomial is actually a negative 1. X cubed y, again, is the same variable here, the same variables here that show up here. So 4 and negative 1, those are the two coefficients that we can combine because these are like terms. So 4 minus 1 or 4 plus negative 1 gives you 3. 3x cubed y. All right, so now it's your turn to do some addition and subtraction. All right, we have two problems here. This is the sum. So collecting like terms here if possible, and here's your difference. Now don't just assume that we always give you like terms. Always double check and make sure that the variables and exponents on the variables are identical for both terms before you ever just start adding or subtracting. Pause the video, here's your answer choices, and add and subtract there if possible. All right, hopefully you're coming back, you've paused the video and you've worked this out. Here is your answer. The sum is 5x to the fourth, and the difference is negative 5 x squared y to the fourth. All right, here's your solution page. You just simply add those two together to get the 5 to minus 7, subtract those to get the negative 5. You keep your variables and coefficients the same.
In this problem, you will classify polynomials. Write the polynomial in standard form. What is the name of the polynomial based on its degree and number of terms? Part A, 3 times x plus 4 times x cubed. To write the polynomial in standard form, place the terms in order from greatest to least exponent.
Standard form is just simply rewriting the polynomial, and be careful of the signs, addition or subtraction, in front of your coefficients.
The degree of the polynomial is 3, and there are 2 terms. So the polynomial is a cubic binomial.
All right, so you have a definition for the degree of a polynomial. Okay, the definition for that was one variable is the same as the degree of the monomial. Well, the degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. Okay, there are 2 monomials here. That's why it says 2 terms, 4x cubed plus 3x. Those two, you look at their degrees individually. The degree of this one is actually 1, and the degree of this one is 3. So individually, you look at their degrees, and then you pick the largest one. That's the reason why we went with 3. Cubic is another term for 3 to the third power. When you cube something, you raise it to the third power. So we would classify this as a cubic binomial. Bi meaning 2. You've also had that definition as well.
Write the polynomial in standard form. What is the name of the polynomial based on its degree and number of terms? Part B, 4 times x minus 1 plus 5 times x squared plus 7 times x. Again, place the terms in order from greatest to least exponent to write the polynomial in standard form. Now, combine like terms. Why do you need to combine like terms? To name a polynomial correctly based on its number of terms, you must first combine all like terms.
So basically what it's saying is, don't tell me that there are 4 terms here. Right now you see 4 terms, but you have to completely simplify this polynomial to determine exactly how many monomials it actually has within it. So always simplify.
The degree of the polynomial is 2. And there are 3 terms. So the polynomial is a quadratic trinomial.
Anything raised to the second power or anything that has that degree of 2 is considered quadratic, and trinomial meaning 3. There are 3 monomials.
Now it's your turn.
All right, here is your polynomial. You need to write it in standard form first. Remember, definition of standard form is that the degrees of the monomial terms are in descending order. So you start with the largest exponent and go down from there. And then once you've done that, you need to identify it based on the degree and the number of terms. Now here are your answer choices. Pause the video and work on that real quick. Your answer to this is D. Once you put it in order, you have 8x to the third plus 2x minus 3. The largest exponent you have is 3. That's the degree. There are 3 terms, so it's a cubic trinomial.
In this problem, you will add polynomials. The number of overnight stays in thousands in U.S. Park Service campgrounds and in the backcountry of the National Park System can be modeled by the following polynomials. Campground. -7 1/10 times x squared minus 180 times x plus 5,800. Backcountry. 21 times x squared minus 140 times x plus 1,900. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry?
Okay, basically all of this right here is the information that you've been given. This last little bit is some extra information, but they didn't, you are not coming up with this polynomial. This is information given to you. But if it's talking about the total number of something, if you're trying to come up with the total number of items you purchased at Walmart, think about what operation would you use to figure out how many total number of items you purchased. So the same thing applies here.
What do you know? You know a model for overnight stays in campgrounds. You also know a model for overnight stays in backcountry. What do you need? You need a polynomial for the total number of overnight stays in campgrounds and backcountry. So what's your plan? The word both implies addition, so add the 2 polynomials to find a polynomial that represents the total. One way you can add these polynomials is to add vertically. Line up like terms, then add the coefficients.
This is like elementary school addition where you line everything up and you add straight down. This is very similar to what we did when we were solving systems of equations by elimination, and we used addition or subtraction vertically.
First, add terms with x squared. Then add terms with x. Finally, add terms that are constants.
One thing you have to be very careful of, you've got -7.1 plus 21. So be careful with the signs. -180 plus -140. So always be very careful with your signs.
Another way you can add these polynomials is to add horizontally. Group like terms, then add the coefficients. First add terms with x squared. Then add terms with x. Finally, add terms that are constants. Now, simplify the expression. A polynomial that models the number of stays in thousands in campgrounds and backcountry over the 5-year period is 13 9/10 times x squared minus 320 times x plus 7,700.
We will go over more of these once you return to class, but make sure you know how to add the two different methods for adding or subtracting polynomials.